The Wildcat HMA2 begins to replace its predecessor, the Sea Lynx, in worldwide. It is the most advanced light naval helicopter today. So many countries seeking a system in this class are closely following the Wildcat HMA2 and its derivatives. The cub of the legendary Lynx is ready to write its own saga. As the weapon detective, we're investigating the naval version of the AW159 Wildcat and its place among the bigger modern naval helicopters. Please don't forget to subscribe to our channel before we start, and give us a thumbs up if you like our video. To be notified of our new video, please click the bell button. The Wildcat HMA2 is unique in the lightweight naval helicopter market compared to its rivals from the previous generation. Of course, the fact that Western navies have turned to heavy and middleweight class naval helicopters since the 1980s is another reason for this situation. We will talk about this later. But first, let's take a look at the history of the AW159's naval model. This video is only about the Wildcat HMA2 and its derivatives in the international market. In the mid-1990s, the Royal Navy was planning to replace its Lynx helicopters with the Merlins. But Westland Helicopters was not ready to give up. The company managed to convince the Royal Navy about the importance of lightweight naval helicopters. In 2002, the British government approved the Future Lynx project, consisting of two studies to determine the suitability of a derivative of the Super Lynx 300 to replace the existing Army and Navy Lynxes. The project had two sub-programs called the Surface Combat Maritime Rotorcraft, shortly SCMR, and Battlefield Light Utility Helicopter, shortly BLUH. In 2000, Westland Helicopters merged with Italian helicopter manufacturer Agusta to form Agusta Westland. Later, this company continued the project. In 2002, Agusta Westland received a contract for the study phase of the Future Lynx project. In the same year, Thales Group joined the program to develop core avionics, including communications, navigation, and flight management electronics of the new helicopter. After the study phase, based on reports, it was decided that the option of upgrading and remanufacturing the early Lynxes is uneconomical. New generation airframes building was the most suitable solution for helicopters to be supplied under the SCMR and BLUH programs. In 2005, the UK chose Agusta Westland as the sole source instead of launching an open competition for other companies to bid for its lightweight helicopter requirement. 1 year later, the UK signed a £1 billion contract with Agusta Westland for production of 70 Future Lynx helicopters. 30 of these rotorcraft would be naval variant, but in 2008, this number was reduced to 28 helicopters. On April 24, 2009, Agusta Westland announced that the Future Lynx is named as AW159 Lynx Wildcat. On November 12 of the same year, the naval version of the helicopter, designated with the name of Wildcat HMA2 by the Royal Navy, made its first flight. The Royal Navy received their first new helicopters in 2013. After 2 years of extensive trials, the Wildcat HMA2 became operational. Besides the UK, the Philippines and South Korea have preferred this helicopter. Agusta Westland, today's Leonardo Helicopters, is the main contractor of the project, while Selex ES, GKN Aerospace, LHTEC, General Dynamics UK, Thales UK, and GE Aviation are main subcontractors. The AW159 looks like a variant of the Lynx, yet they are quite different helicopters. Nearly 95% of its components are new. For example, the Wildcat HMA2 has a new composite tail boom, tail plane, tail rotor, nose structure, and avionics suite. The Wildcat HMA2 has 4 flexible BERP4 rotor blades with backwards angled ends. Each blade is connected to the rotor head by titanium panels. The lifespan of the corrosion-resistant fuselage is over 12,000 flight hours. The strengthened landing gear is suitable for ship-based operations. These features are common for both Army and Navy variants. Actually, component compatibility between the two versions is around 98%. This has provided a significant cost advantage in terms of development, production, and logistics. The access panels and doors, as well as housing of the engine and gearbox, are in carbon fiber. The ends of the light alloy tail rotor are steel. For emergency, the cockpit doors can be jettisoned outwards, allowing the crew to easily leave the helicopter. Thanks to its more powerful LHTEC CTS 800 fore-end turboshafts, the maximum takeoff weight of the Wildcat HMA2 is more than 1 ton over the Super Lynx. Also, the alloy-made fuselage is lighter, so its payload and range are higher than its predecessor. A Wildcat HMA2, armed with anti-ship missiles, can remain on station for up to an hour. Also, it can fly for more than 2 hours when equipped with one sonar and lightweight torpedo, and more than 1 hour when equipped with two sonar and lightweight torpedoes. The Wildcat HMA2 has a two-man crew. It can also carry 6 passengers. The helicopter is 15.22 meters long and 3.73 meters high. Its rotor diameter is 12.8 meters. The maximum takeoff weight of the Wildcat HMA2 is 6,050 kilograms. Two 1,016 kilowatt LHTEC CTS 804 and turboshaft engines provide the maximum speed of 290 kilometers per hour. The maximum range of the helicopter is 778 kilometers. The Wildcat HMA2 can climb the altitude of 4,570 meters. Its hover ceiling is 2,347 meters. The endurance of the helicopter is 2 hours and 40 minutes. The X-band Sea Spray 7000E active electronically scanned array surveillance radar of the Wildcat HMA2 has the maximum range of 370 kilometers. It can track over 200 targets simultaneously. The Korean AW159s has Sea Spray 7500E radar, which is a larger version of the Sea Spray 7000E. These two radars have similar capabilities. While the Royal Navy prefers the MX-15D forward-looking infrared system produced by L3 Westcam, the Republic of Korea and the Philippines have the MX-20 in their helicopters. These systems have laser illumination capability for missiles. The Royal Navy will equip its Wildcat HMA2s with the Sea Venom missiles. MBDA is developing this missile to replace the Sea Squaa and AS-15 TTs. This missile, with a 30-kilogram warhead, is originally designed for use against small ships which have the displacement of between 50 to 500 tons. The first test launch of the missile was conducted on June 21, 2017. The Sea Venom has completed its qualification firing trials successfully on November 17, 2020. The Sea Venom has an infrared seeker guidance system. Thanks to its high-speed, two-way RF data link option, the operator can observe the target area and change the target during the cruise phase if necessary. Its range is about 20 kilometers. The missile is effective against a wide range of targets, both sea and land. The Royal Navy is expecting that the Sea Venom will reach initial operating capability in 2022. Depending on mission definition, the Wildcat HMA2 can carry 4 of these missiles, which has 110 kilogram weight. But South Korea and the Philippines do not want to wait for the Sea Venom. So these countries chose the Spike NLOS of the Rafael for the same mission. This missile has the electro-optic charge-coupled device camera seekers and 25 kilometers maximum range. Also, the Wildcat HMA2 will use the Martlet light missiles. Within the scope of the future anti-surface guided weapon light program, This missile is developed to respond to today's asymmetric threats. For example, today, Iran has a concept that intends blocking the Strait of Hormuz, one of the world's most important waterways, with hundreds of mini-boats in case of war. This concept is an adaptation of the Toyota War to naval warfare. Current major surface combatants do not have sufficient defense capability against an attack group of 20 to 30 mini-boats carrying artillery rockets, anti-tank missiles, or 23mm cannons. Launching a relatively expensive missile, such as a Sea Venom, Penguin, or Hellfire, against each of these boats is not cost-effective. Besides, a naval helicopter can carry low amounts of these missiles due to their weight, whereas a Wildcat HMA2 can carry 4 launchers, each with 5 Martlets. These missiles, with a range of 8 kilometers, can prevent an attack group of mini-boats before they approach the distance that would pose a threat to the ship. Its 3 kg shaped charge fragmentation warhead is enough to stop such small boats. With its laser beam riding and/or semi-active laser guidance and terminal infrared homing options, the Martlet can engage multiple threats simultaneously. This multi-mode guidance system also allows the missile to be used effectively against land and air. Developed by Thales, the Martlet will be operational in 2024. Its fire trials were conducted in 2020. For the anti-submarine warfare mission, the Wildcat HMA2 uses the Stingray lightweight torpedoes. The navies of South Korea and the Philippines prefer South Korean Blue Shark torpedoes. Now, let's analyze why lightweight naval helicopters are a necessity. As we have mentioned before, since the 1980s, the Western navies have preferred heavy and medium-weight helicopters because their carrying capacity is higher. Thus, they can carry more electronic warfare systems, self-defense systems, and weapons, as well as larger and more capable radar and sonars. Their endurance is higher. Yet, they occupy much more space on the ship. A Type 45 class destroyer can carry a Merlin HM1 or 2 Wildcat HMA2s. Of course, this does not provide a significant advantage in aircraft carrier escort missions. However, it brings an important advantage that a Type 45 carries not 1 but 2 helicopters while it is patrolling alone. First of all, 2 helicopters in the air can control a much wider area. Besides, when one helicopter needs maintenance or repair, the other helicopter is still operational, which can be vital for a surface combatant patrolling alone. The Wildcat HMA2 allows the Royal Navy to perform missions in different regions simultaneously without being dependent on aircraft carriers. Let's look at the scenario about the war around the Strait of Hormuz again. The helicopter, which is on anti-surface warfare mission against an attack by a large number of mini-boats, has to return to its mothership to resupply after intensive combat. During this time, the second helicopter can stand in the air ready for possible second attack group. Today, the displacement of frigates has exceeded 5,000 tons. However, many older frigates didn't have aviation facilities which are suitable to operate a heavy or medium-weight helicopter. Many countries prefer corvettes instead of large frigates, whose operating costs increase in parallel with their weight. There is a need in the international market for a modern lightweight naval helicopter that can be used on these ships. The ship-based model of the AW159 fills the gap in this market. The lightweight naval helicopters are not as expensive as their heavier counterparts. It should not be forgotten that many countries prefer cheaper systems because of their economical situation. Some navies are still using the previous generation Lynxes. Replacing these aging helicopters with a heavy one will require extensive modification of their ships. This is not a feasible option for them. So, the AW159 is one of the most prominent naval helicopter programs of today in the market. Thanks to its well-decided design, the Wildcat HMA2 can answer the modern naval warfare requirement in a wide range. Also, it is one of the most cost-efficient solutions. As a weapon detective, we believe that the Wildcat HMA2, the cub of the legendary Lynx, will make a name for itself in the future with its operational and market successes. Thanks for watching our video, and please don't forget to subscribe to our channel and give us a thumbs up if you like our video. To be notified of our new videos, please click the bell button.